Okay, so integration. Here's a run through some simple integration questions that I think will really help you with your exam. There are some simple familiar questions in the exam, and if you can do these, you'll be able to do those, and it's certainly a bonus to your marks. So let's go. First of all, just recall that integration is the reverse of differentiation, sometimes called anti-differentiation, but more generally called integration. So we are working in a system where we are just reversing the process of differentiation. So just keep that in mind. So here's some examples. The first one we're going to do is integrating sine 2x. So the first thing you need to do is recall that when you integrate sine of anything, it goes to cos of that thing. So cos 2x, and it's the reverse of differentiation. So when you derive cos, you actually get negative sine, which means if you integrate sine, you get negative cos. So you have to just go back and practice that, the relationship between sine and cos in differentiation and integration, perhaps. When you integrate a function where the inside component, that is this bit here, is not just x, then you have to be a little bit careful, particularly if that's linear. So as that's a linear term, then we now need to make sure that we take into account that if we derived cos 2x, we would end up with an additional factor of 2 from the derivative of the inside function. So it's a chain rule thing. So we have to cancel out that additional factor of 2 by dividing by 2 as we've done here. So that's how we cancel that out. And of course we've got a plus c. And my final answer might look something like this, but you know, there's many different forms and it doesn't really matter how you write it. As long as it's got the negative, the half, the cos 2x and the plus c, this question would probably be worth 2 marks, and the marks will be allocated half mark there, half mark there, half mark there, half mark there. So even if you make a small mistake or you forget the plus c, you can get most of the marks out. You note I said earlier that particularly if this component is linear, as it turns out, if that component isn't linear, if the inside function isn't linear, you've got a harder question. You've got either an integration by recognition type question, or you've got a question that's beyond the syllabus. So now, once we get into these more complex examples, expect that inside function to be linear. If it was sine of x squared, you can't actually do that. So the integration should look and be probably a bit simpler than some of the differentiations that you do. So just scooting down, my second example will be this purely polynomial one, but it's a polynomial with a power. It looks like, and I say this loosely because it's not a differentiation question, so it's not chain rule, but it's got that look of a chain rule, which tells you can integrate it using the same concept. We have an inside function here, and we have an outside function of to the power of 7. So when we integrate a polynomial, we do that first, we get 5x plus 4 to the power of 8. So when you integrate a polynomial, you raise the power by 1, but then we divide by the new power, 8. But we also have to divide by the derivative of the inside. So that is the derivative d dx of 5x plus 4. And again, you should be noticing now that commonly that will be a linear term. So we have to multiply by the derivative of that, which is 5, or divide by, which is multiplying in the denominator. And this simplifies down to be 1/40th of 5x plus 4 to the power of 8. And of course there's a plus c there and a plus c there. Make sure you've got a plus c at every stage after you've applied this integration sign. So as soon as I remove that integration sign, a plus c appears. So there we go again. That's probably a 2-mark question again, and there's probably half a mark allocated for leaving the polynomial the same, not writing it as x squared over 2.5x squared, etc. And there'll be half a mark allocated for the power, half a mark for the 1/40 fraction, and half a mark for the plus c. Something along those lines. Here's the next one. Now the next one's got a couple of components in it. So you have to remember that whereas the previous examples only had one term, this has got plus in the middle of 2 terms. So there's 2 separate things going on here. So I'm going to integrate both of them separately, but because my integration sign is across both, I'm going to simplify them until I'm at a point where I'm happy to integrate, and I'm going to integrate them both at the same time so I don't get any confusion in my notation. So let's have a look at this in process. The first term is actually already pretty well done. So what I'm going to do is I'm going to write it down as 6 times 1 over 3x minus 2. That just helps me to understand that that 6 doesn't have to be part of the integral. And in this case, it's easier if it's not. So I'm going to write 6 times that, and then I'm going to write plus e to the power of negative a half x. So I'm just applying that negative indice concept to transform e to be e to the power of negative a half x. And of course, I've still got dx. Now this is at a point now where I can integrate both of these terms separately. This being the first term, and this being the second term. So now I'm going to integrate, so I'll remove the integration sign. I've now got 6 log 3x minus 2. But of course, I've done an integral on this 3x minus 2 in the denominator to get it in terms of the natural log, but I have to divide by 3 here. Because if I derived this term, I would end up multiplying by a factor of 3. So I've got to cancel that out in my process. So I divide by the derivative of the inside function, which we did on the previous questions. Plus, remember when we integrate an e to the power of, we get an e to the power of the same thing. The power does not change, but I now need to divide by the derivative of the inside function, which is the derivative of negative 1/2 x. So when you have e to the power of negative half x and you integrate it, it stays the same. That e to the power of anything, it stays the same. And this is an exponential because x isn't a power. So you can't treat it like a polynomial and raise the power by 1, which I have seen people do in the past. Of course, we have a plus c because we've integrated now. And so now we just do our cancelling out. So we get a half log 3x minus 2. And over here, when you divide by negative a half, it actually makes it negative 2 e to the negative half x plus c. Interestingly, you should be able to see how this changes the question. So that is wrong. So 6 divided by 3 is not a half. That's 2. That's now permanently etched on the video. Oops. Anyway, you should be able to get a feel of whether you've done things right. If you derive this, you would get 1 over this thing here, and you would multiply by 3, which would give you the 6 there. So I'm pretty confident that's right. If I derive this, I would get itself, which is what I started with, but I'd have to multiply the outside by negative a half, the derivative of the inside, which would cancel with this negative 2, just leave me with 1. So this works. I can see it works, and the constant would obviously disappear. So I know I've got the right answer. This question would probably yield 3 marks. Again, the exam's only out of 50 or 55, so 3 marks is quite valuable, 5–6%. This would yield 3 marks. It would yield the marks probably 2 of the marks for getting that log function right, 1 of the marks for getting that, also a mark for getting the log function right, half a mark for getting that right, a half a mark allocated for the 2, a half a mark allocated for the negative 2, and again, there's probably half a mark allocated for the plus c. That will happen, the plus c half a mark, at least twice in your exam, so watch for it. My last example I was going to do with integration is this function here. This is fairly common, and we've done them in class, and you've seen them in your textbook work. But I'm going to make sure that you get it right, because I've seen some really weird and wonderful things, particularly in the last formative task of what people have done. And I want you to make sure that you're getting these right. What we have is 3 separate terms. They're separated by the plus and the minus. So we can't integrate this in its current form. We have to simplify it by recognizing that each of these terms is divided by this common divisor, 2x squared. So I'm going to write this out as the integral of x cubed over 2x squared minus 6x over 2x squared plus 4 over 2x squared dx. Every term is divided by that. Now I have 3 separate terms. When I integrate this, the x cubed divided by 2x squared gives me a half x. And that's pretty easy to integrate, a half x. And when I divide the next one through, 6 divided by 2 is 3. But of course I end up with 3 over x. That's not too bad either, honestly. And the last one is 2 over x squared dx. Now, the first 2 terms are fairly easy to deal with. The last one's still a bit tricky. I have to just make sure I make one last rearrangement of that. Half x minus 3 over x plus 2x to the negative 2. With respect to x, now I recognise that I can integrate each of these terms. So I get a half, I raise the power to 2 and I divide by the new power. because that's a polynomial. This one is a log, because it's just 1 over x times 3, so it becomes negative 3 log x. You'll note there's no function on the inside, so I don't have to do any special deriving this time, and dividing by the derivative, plus 2x to the negative 1. I've raised the power by 1, and negative 2 plus 1 is negative 1, divided by the new power, which is negative 1, plus c at this stage, and this is equal to a quarter x squared minus 3 log x minus, that's what the negative 1 does, and then 2 over x plus c. So that last term is the trickiest one to transform, but that minus 1 has just become the minus there. X to the negative 1 has just become the 1 over x, and of course I'm left with that 2, which I've really done nothing to, and left there. So that's all my examples, I believe. So that was what I was going to do in our lunchtime session, and I'll still provide you that opportunity. But for now, you're welcome to have a watch of this video. You're welcome to come and ask me specific questions about elements of the video. But hopefully, you will practice these questions and these types of questions, and you'll get them right in your exam. The last thing I've forgotten to do is just probably allocate some marks to this. It would probably, again, be 3 marks. There'd probably be half a mark for recognising that you need to split it up, and there'd probably be a full mark for doing the split up correctly, or maybe half a mark for these two together, and then half a mark for that one, and then there'll probably be half a mark allocated for each of the final integrations, and maybe or maybe not a half a mark allocated for the plus c. The plus c is probably going to come up in the easier questions, so make sure you get that right. Okay, and that's it. Thanks for watching.